Welcome. Thanks for joining us. So we're here, we're going to talk tonight a little bit about engineering in early childhood. We're here talking about preschool and kindergarten, and it's often not a group that we immediately think about as engineering. And we want to make sure that this is something that everybody sees them as capable of doing, that it's this fun experience. And I've invited Dr. Amy Long from Commonwealth University to talk with me tonight because she is far more of an expert with the littles, as I call them, than I am. She has a lot more experience with them, both as a teacher, a professor, and a coach. But we'll get to that in just a minute. I have to be able to move slides, though. There we go. All
So
right.
tonight we're going to cover a number of things. We're going to start, as Katie just mentioned, with some introductions, and then we're going to focus heavily on these three questions that you see on the screen, and we'll dive into each of these. But why should early childhood classrooms engineer? Like, why are we even here? What's the purpose behind this? What does it look like in early childhood? And then what are some resources that are available? And there's a lot of different resources that Katie's going to share with you in the second half of tonight's webinar. But we're going to show you some examples, talk about some different curriculum, share different experiences that we've had working with engineering with young learners, and then we're going to wrap up with any questions or comments that you have. So as Katie mentioned in the beginning, please feel free to interject with a question if you want to raise your hand or ask it in the chat. But also we'll have a specific time set aside at the end, if after you've heard everything, you still have some burning questions you want to address.
Awesome. All right, so I'll get started. So as you've kind of heard us mention our names already, but for those of you who are not familiar, my name is Dr. Katie Bateman. I am a professional learning and research manager with the Museum of Science, Boston. So my area of expertise is really in STEM education. I've worked with everything pre-K through 16 in engineering, in all of the sciences, in math and technology. So we do computer science as well. And I am excited to get to talk about doing this with our early childhood and preschool folks because it's such an interesting age to be doing this with, and they get so excited. We're going to see lots of video tonight from a kindergarten classroom that I got to be in that was just pure joy for 2 weeks of, getting up and it's 8 a.m. and they are just so excited to be there and to be engineering and solving a problem. I'll hand it off to Amy.
I am Dr. Amy Long, and thank you, Katie, for inviting me to co-host with you tonight. I am an assistant professor of early childhood education, pre-K to grade 4 teacher certification in Pennsylvania at Commonwealth University on the Lock Haven campus. I do see Dr. Stutzman has logged in. She teaches in Commonwealth University on the Bloomsburg campus. So, Amanda, feel free to chime in if anything comes up that you want to share as well. As Katie mentioned, I have a lot of experience in early childhood. I also have a 5-year-old, a 4-year-old, and a 2-month-old, 3-month-old kiddos of my own who I'll share a couple things as we go through and hit on some of the key components of engineering in early childhood that my own children do, in addition to the things that I see within the classrooms that I work. So we're excited to be here with you tonight, and I think we're ready to dive in.
Awesome. All right.
We're going to start with a really short video clip just to address why engineering in early childhood. Katie mentioned she spent some time in a kindergarten classroom, so this is one of the teachers sharing their experiences. But really, we really want to foster, when we think about engineering in early childhood, we want to foster engaging our young learners in their natural curiosities, right? Little kids, if you spend any time around them, which if you're in this webinar, I imagine you have, either that's your job every day or you're preparing for it to be. But little kids are so curious about everything around them, and they'll ask a million questions. And we really want to foster that with engineering rather than squash it. So let's listen in on this teacher sharing her experience.
Engineering is important for preschool students. because it really is a process that they're going to have to learn and explore their whole entire lives. It's really a process of solving problems and learning about disappointment and learning how to sort of bounce back when something's not working the way they want it to.
Am I going to the next one already?
Yes, thanks.
Engineering is
Oh, it does that every time. One of these days I'll figure out how to not make it do that.
She just wants to keep telling you, but it's important, and she raises a good point, right? Those are skills that engineering are skills that we want students to develop and work with over their entire lifespan. So here are 4 key components. We're going to go into each one of these just briefly before we dive into what this actually looks like in early childhood classrooms. So the first is that children can and should shape their world, that engineering builds lifelong skills. And that's one of the things that the teacher just mentioned, right? We're starting these processes so kids are able to do it throughout their lifetime. That engineering is playful and that it's interdisciplinary, and there's so many opportunities for it to be interdisciplinary. And we'll look at a couple here tonight. And that children need to see themselves as engineers. They need to feel confident that they can be successful, they can be problem solvers. And even if things don't work, that they can go back and reiterate, and they can solve things multiple ways, or they can fix what didn't work and try again. And that's a really important skill for young learners to learn and experience. They don't just throw themselves on the floor in a tantrum when something doesn't work out, but that they have opportunities to fix it. So these are the 4 areas that we're going to really focus on as we think about engineering within early childhood.
Buttons. Am I hitting play right away?
Sure.
Is she awake today?
Hi guys!
Hi.
Hi, are you ready to do some engineering?
Yeah.
Take a thinking minute and help me remember, what do engineers do? Oh, wait, hold on though, hold on. Ari, what does an engineer do?
Figure out things.
Figure out things, Esme?
They help you make a shoe.
They can help you make a shoe, you're right. Elizabeth?
They build.
They build. Gia?
They build.
They build. Ethan?
They make your shirt.
They make your shirts. Somebody mentioned that shoes were engineered. Somebody figured out how to make shoes. What would happen if we didn't have shoes?
You could just wear socks, but then you couldn't walk outside because then you couldn't have any shoes.
You're right.
You could
just wear socks, but then when you walk outside and it's snowy, what would happen?
The socks will really freeze.
Your socks will freeze. And
Or they'll melt.
Or they'll melt. What's inside of your socks though that you need to keep safe?
Your feet.
Your feet. You're right. I'm so glad an engineer figured out how to make your shoes.
That video shows a really nice example of the kids starting to understand that their world, the things that are important to them that they need, for in this example for shoes, right? That those things were designed, they were engineered. So it can really help get them in that mindset of, hey, I can build something to solve this problem. I can do something to solve this. And I'll try not to give too many examples of my own children, but I've been experiencing this lately. My son we're trying to figure out exactly what it is, but he's been working hard to build this structure outside. I believe it's to store his materials, his little kitty wheelbarrow and his tools.
Oh,
But he made a list of things he needed to get from Lowe's, and he wants some bricks, which we didn't have. We weren't sure what he was trying to do when he was saying he needed bricks, but then he took his wheelbarrow and he got some big stones like river rocks. And so he's figuring out how to build that, how to construct this, whatever the structure is that he needs to solve his problem of where is he going to keep his tools and his materials outside. So I've been seeing as he's been working on it for weeks, every weekend for the past couple weeks. So I can really see how he is designing, if something doesn't work or like he didn't have bricks. So he's figuring out what else can I use, using stones, things like that. this is something that, of course, is unstructured. He's just doing this in his free time, but he's really working to solve a problem and to hit on this standard that we're looking at, which is shaping their world, right? Seeing something that needs to be addressed and then working hard to address it. And I'm sure Katie can imagine him doing this, as she knows him quite well.
And I was thinking too, it's not just, there's a difference between loose parts play and engineering. And I think that big difference is he's got a very specific problem. He's not just building a tower out of Legos, which is great too. There's a reason to be doing all this loose parts play, but he's got a very specific task that he's undertaking, even if we as adults can't understand it all the time, right? There's a very specific thing he's trying to accomplish. And he's using, it seems, a very structured problem-solving process. He's got a plan. He's got a list.
He does.
He knows what he needs. And yes, very typical of his personality, and maybe not all preschool and kindergartners. But that's the, the kind of things we want them to see, is that they can take control of their world. They can make things happen for themselves and enact change, even if it's tiny, even if it's figuring out how to make a, fake shed in your backyard for your cars and your tools.
Right.
Sounds like spending time with his dad, it sounds like.
Yes. Well, his dad was a little unsure of what he was doing, but it's becoming clearer. But it has used, yes, a lot of components. But I'm glad you brought up that difference between the loose parts play, because sure, he does that all the time as well. But these are, very different things, and they look very different because he is trying to solve a problem with this building, and he is engineering it. I mean, he really is thinking through what are the different components, how big does it need to be. He has his list of materials, like really being purposeful and thoughtful, and it's different than just unstructured play. So I think that's one thing to keep in mind too, as we as teachers are thinking about implementing different types of engineering in our classroom, is how is it still that open creativity where the children have control and they're shaping their world, but that it's not just free play, right? That it is structured and purposeful. And so I think, some of the resources that you're going to share later on really help with that, with narrowing in.
Yeah.
Anyway, do you want to flip to the next slide?
Okay, let's talk about creative. There we
go. So you'll see on this slide, if you're familiar with the 21st century skills, which I could talk about for days, so I'm not going to. They're on this slide because the core 21st century skills are listed here, and that's communication, collaboration, critical thinking, and creativity. And, about 10 years ago, there was this push about, we need to really utilize these skills to get kids ready for the 21st century. Well, guess what? We're in it, and we've been in it for 24 years, right? It's too late to be getting them ready for the 21st century. We're in the 21st century. And, the students that we're working with, a lot of the people possibly in this webinar right now were born in the 21st century. So it's not about getting ready for the 21st century or getting ready for 21st century careers, because it's already here. What the careers that we have now, these are 21st century careers, right? So these are the skills that have to be a part of our everyday instruction. And some of them can come really easily when we think about early childhood, like creativity. Little kids are so creative, right? They are deeply engaged in imaginative play. Creativity comes pretty easily. What is a lot harder for our young learners is communication. Sometimes they have an idea in their head and they get so frustrated because they can't verbalize what it is that they're trying to do, or what they even need to do it, maybe. Like they might have a vision in their head, but they don't know exactly what tools to ask for, right? They don't know. I'm just looking at the one picture, like they might not have the word for paperclip. And so they know that's what they need or what they want, but they don't know to ask for that. So that's where we as the teachers, as the caregivers, as the parents need to help facilitate that, to give them some of the language to help them communicate, and also to help them communicate, their results, their findings, their changes. My son, who I just mentioned a moment ago, he has a STEM teacher, and he's in kindergarten. He has a STEM teacher at the school that he's at, and they just brought home their first STEM notebook. And I actually forget what they were doing. It was something with a rock. They had to disguise a rock. I don't know, but you can see his plan where he drew, what he was going to do, and then what changes he made. And so communication can be scaffolded, and it can be simple. It can be talking about it. It can be drawing it. It could be writing about it or labeling parts. That's all a part of communication.
Yeah,
The other
that's
one that
that
can,
multimodality that's so important for our learners to develop, right? That there's not one way to communicate. It's multiple
sure,
ways that they can communicate.
yeah, and it can be a combination of things too, right? I think the other one that can be really hard in early childhood, although we see it here in some of these images that you took, is the collaboration part. We know, and it's typical and it's developmental, that early childhood students are very egocentric, right? They want to do things sometimes on their own. It's just about their plan, and it can be hard to incorporate other people's ideas, but those are all learning opportunities for them, right? This is where you as the teacher can teach them how do we take turns, how do we work with one another, how can I incorporate Katie's idea with my idea. And you'll see, whenever, if you first start to do this, or kids don't have a lot of experience collaborating, where somebody bursts into tears because they want to try their idea, and maybe they're working with partners and the partner is not open to it, right? And so how do you teach them those collaborative skills? Like, well, let's try Katie's idea first and then we'll try your idea, and all
Mhm.
of that can be modeled and scaffolded, but these are the critical components that we want to build starting with our youngest learners, these 4 C's, to help them develop these lifelong skills, both for engineering and just for life, right? Just being able to think
Absolutely.
critically and be creative in as a person in this world, so they can utilize it, they can learn it, we can teach it through engineering, but it's applicable all across the board.
Yeah, and that's one of the things we'll start to see. We'll see it actually with these two little girls in the bottom right corner of your screen in a little bit, that like how that's scaffolded and how that talk actually looks when they have the appropriate scaffolds to be able to do all of these. I'm gonna take us to the next one, keep us moving here.
Yeah. So engineering is playful and interdisciplinary, and anyone that again has worked with young students, you know, as soon as you put a material on the table, even if you say do not touch it, put your hands on your head, nobody touch it, they're going to touch it, right? Kids are naturally going to play with materials, they're going to explore with things, even if it's something that they have explored with a million times. Um, they're going to want to play around, and if you think about it, that's what a lot of engineering is. It's tinkering, it's playing around with multiple materials to try things out. And so that feeds naturally for students, especially at this young age, where it's just intuitive for them to play and explore and try things out.
They
So
ask a
that's the
million questions, right?
yes, yes.
They're always asking questions.
So that's the first key component, and the second part is it's so easy for engineering to be interdisciplinary, which is crucial in early childhood. You need things to be interdisciplinary. You often have kids with you for just a short time, or even if it's a full day preschool program or full day kindergarten, often the instructional time is really short because young kids have shorter attention spans, or they have other things that they're doing throughout their day. So it's really important for it to be interdisciplinary. And you can see here in this image, the teacher is reading a book. It's easy to tie literature in as as a guide or an overarching, we're going to use this book to sort of lead our engineering, but also as a resource, to say to a child, well, let's look at a book and let's look at how some buildings are structured, right? If they're building something, like let's look and see, let's look at the pictures, let's look at the words, let's see if we can piece this together. And of course, incorporating math, social studies, things that are happening around the world. I often think this is older than early childhood, but I was a second grade teacher in 2010 when the huge BP oil spill happened in the Gulf, and it was months of on the news and the cleanup, and I had this student that designed, just of his own accord, he was hearing about how detrimental this was to the animals. He designed a filter to clean up the Gulf of Mexico, and he's like, he built it, this model, and said, like, oh, I think they could do something. And we talked about how it worked. We tested it, it worked on a small scale, but how can we build it on a large scale for the entire Gulf of Mexico? That was part of the problem. But a way to tie into current events. And this wasn't part of a lesson. This was just something the student happened to do of his own free time. But that's a example of how you can make things interdisciplinary and just really tie in these 4C components that we were just looking at and the different disciplines that you need to cover throughout your academic day. Katie, were you going to say something and then I just continued talking?
Nope, I accidentally advanced the slides because my Apple mouse is very sensitive. And so if you look at it the wrong way, it decides to change the slides. So
So what's on the right of your screen? I think somebody just put in the chat. I didn't read it carefully because I was talking, but they can't really read what that says. That's an example of the curriculum that we're going to go over and show you how to access later on in this webinar. That shows how the different engineering lessons and curriculum we look at tie in to the next generation science standard. So you don't need to be able to read what's on that slide now. That's just an example page. We're going to show you how you can access all of that.
yes. All right. This is to me is one of the really important ones, Amy.
It is. It absolutely is. So where children need to see themselves as engineers, right? That they need to see that they can do this, that engineering isn't just something that, somebody does in their office far away, but that they are engineers, they are problem solvers, right? And again, that example that I was just sharing with my student who designed this filter for the oil spill, but he was able to see himself as like, hey, wait, I can fix this problem, right? Would it really work? No, but that doesn't matter. He saw himself as an engineer. And I see that a lot with my own kids, particularly my son, who is a little bit more into building, into tinkering, into experimenting than my daughter, but she does too, where she'll build different things and really sees herself as not only a problem solver, but a builder, but a designer and someone that can engineer. And that seems intuitive to us if we are, actively engaged in education. And of course, we want to foster this in students, but it so quickly gets squashed out of kids. I feel like around second grade, but maybe even earlier, where they start to learn that school is about having the right answer, right? It's about having the A's on the report card because I get a reward from home if I get good grades,
Get a
good,
sticker.
good feedback. What was that?
You get a sticker.
Yes.
Get a good
yes.
grade, you get a sticker. Everybody loves a sticker.
That's right. And that can really prevent students from being willing to take risks and to see themselves as an engineer who can think and problem solve and design something. You'll see kids if they're not used to doing engineering and you like some of the materials that we show you tonight, you decide I'm going to take this and try it in my classroom. You'll see some students who are paralyzed with not knowing how to begin or what to do because they're afraid to get it wrong. They want there to be a right answer. Well, how do I build this? And there isn't necessarily a right answer. There could be a bunch of different ways that can work with whatever you're trying to solve. I mean, even that example where we saw the kindergarten teacher talking about shoes. Well, let's think about that. There's a ton of different types of shoes, right? We have rain boots when it's raining, snow boots, we have sandals for the beach. So it's not that just one shoe works for everything. There's different types of shoes. That's a pretty basic example, but kids need to be able to see that there are multiple solutions and that they are capable of engineering and designing. And that's so critical for our early childhood students. And I feel like early childhood teachers are so good at fostering that. Yeah. But then once it gets into a little bit more structure of elementary school, that's where it tends to get squashed out. And I think, Katie, we're working here and the higher ed side to fix that problem.
Ooh, we're trying.
But, one step at a time.
Well, that's Christina just put into the chat here. She said, I see this all the time, especially with my older students. And so when I was just doing professional learning, a workshop for engineering for more elementary and middle school yesterday. And we talked about this of, that how good this is for those kids who don't know how to fail. Your kids who have always gotten A's, who have always gotten the right answers, who identify themselves as successful because they don't fail. And then when they do, it becomes a problem because they've internalized this identity of success means never getting it wrong. And if we can get that at these early childhood years where they're thinking, oh, well, it's not that I got it wrong. It's just that didn't do what I wanted it to do. What can I learn from that? And how can I do it better? And that's such the thing we want human beings to be able to do, not just engineers. Right? It goes
Absolutely.
back to those critical skills for life, not just as engineers.
Exactly. And not just for the 21st century, right? But just skills for life, skills for people, I want to say.
Skills, yes.
There's a question in the question and answer. It said somebody said STEM is not enough. STEAM instead, with the A added. What do you think? I think A is already included in engineering and STEM. I think so too. And I typically teach a science methods course. However, I'm on maternity leave this semester, and Katie is covering my science methods course. And I actually would do a whole class session on that. I would tend to use STEAM and STEM interchangeably because I personally also feel like that A is already included, that A being the art piece, because students are drawing out their designs. They or as they're building, or the creativity piece. I personally feel like that A is embedded. There might be some art teachers out there that disagree and feel like the A needs to be a separate piece. I see Katie nodding her head there. But I think that can be a personal decision, right? And maybe that's just my take on it. But I personally feel like that A is included. It doesn't need to be a separate thing. Because sometimes when I see teachers saying, oh, we're doing STEAM and they're doing the A, it's really a guided art project. And there isn't necessarily the engineering component in it. So I'm hesitant to use that A, but I'm sure it can be well done in certain contexts.
It absolutely can be well done. And some of the resources we're going to share, I feel like that there is that sort of embeddedness of it. I was raised by an art teacher who I think would disagree that a lot of things that I would be like, oh, that's STEAM. We're doing art. She'd be like, that's not meeting the art standards. So I think that's the difference, right? Is your intention for them to have that creative freedom? For example, we have a unit where they're designing a bandage, right? Where they're going to have that ability to put their artistic spin on it. And to me, it's the difference between engineering and architecture, right? That a building and engineering design technically just needs to function. Architects are going to bring that and make it look pretty, right? To make it aesthetically pleasing. That's not necessarily engineering's job. That doesn't mean that they can't also do that. So that comes to, we'll see pictures of some jellyfish hats in a little bit from our sun hats from kindergarten, where that was something that student or students in this case prioritized, was they wanted their hat to be fun and aesthetically pleasing, and they decided pipe cleaners as part of their hat was important to them. And so it comes down to letting kids decide what counts as engineering and what's important, and have that agency in their learning too. Right, giving a little self-guided.
Yeah, and there's a comment Christina made in the chat that says, when students see art in the title, they feel seen if they identify as an artist or as a designer. And I think that that's a really good point. And that feeds into what Katie was just sharing, that architecture piece, and again, you'll see whenever we look at some examples of the hats, if that is something that is really important to them, that can be something that, the teacher might want to include, or even point out, right, how the artistic components came through with some of the engineering.
Yeah, absolutely. All right, well, we'll keep moving here. So this is where I'll kind of step in and start to lead a little bit more, because what will engineering look like in early childhood? For most of us, it was certainly not part of my teacher prep program. Amy, I'm sure it was not part of yours either, although both of us teach it with our elementary methods students. It's something we've incorporated because we see how valuable it is. But for a lot of us, it's like, what does that even mean that a preschooler is going to engineer? When we think about engineering is heavily tied to math and statistics and calculus, and it doesn't need to be that, right? So again, I thought I'd let an educator give us a little bit of insight as to what it looked like in her kindergarten classroom.
I think making the sun hat. I mean, kids love to create, especially at that age. So
Jellyfish.
anything hands-on is what they enjoy. It was just valuable to see the success of the students, see how they lit up when their design hat worked, seeing the problem solving and the trial and error when something didn't work. When we tested it, whether the light shined through or not, and did it protect their face and their ears, I think they then, like, the light bulb hit, like they understood at that point, hey, that didn't work. I think they learned what an engineer is and the process of it. I enjoyed the design process, being able to teach that to them. That is not something we ever taught in kindergarten.
So we hear her start to talk about the students understanding what an engineer even is, because that's not necessarily something that they understand. Even all the way up through grown adults, sometimes we think of engineer and we think of the kind of engineer that's a trained conductor, or we have a sanitation engineer. We use that word to mean a lot of things. And so we really make sure with the YES and EIE materials that we make this a clear definition, right? And it's around problem solving, right? We are wanting students to engineer. We want them to be a problem solver and use a process, right? So as we go back to this idea of a structured problem solving process. And so to make sure that that's accessible to students, we need to think about this as developmentally appropriate. So when we're talking about preschoolers, we don't need the sort of more complicated and complex engineering design process that you'd have with a middle schooler. We want to keep this really short, precise, just these three things, right? They're going to explore the materials and what's there. They're going to create something, and then they're going to try to make that thing better by improving. And as we get into kindergarten and elementary school, speaking of preschoolers, that was my 5-year-old nephew trying to FaceTime me in the middle of this webinar. But we see this, improve start to happen. It gets a little more complicated at that elementary school, so that we're improving all of these things to make them better. And so I thought we'd take a little look at just like, what does this look like? And so what you'll see on these slides is you're going to see what phase we're in, and then a little sample of what this activity that they're doing is for our preschoolers. And one of the things to pay attention to is all of these are meant to be built into stations that you already do in your preschool classroom.
Here are the different materials we're going to explore. So you can try picking them up and seeing what they feel like. Try them, pick up different ones and see how they feel. See if they're soft or heavy or hard or light. Those are heavy. Ah, what are you noticing?
These are hard.
Those are hard.
These are
Soft. Okay. What else?
This is hard.
Another hard. Oh, so you found two hard things.
This is soft.
Oops. So that kind of scooped away, but we get this idea that they're investigating the materials, even if they're not doing hard data collection, right? They're not counting, they're not measuring, but they're exploring what these materials might actually mean and how they might help them solve this problem of designing something that can solve as a wrecking ball to knock down a block tower.
And I noticed there's a request to increase the volume, Katie.
Yeah, I think that's
I noticed
video by video.
Yeah, I noticed too, the teacher was really preparing them by asking scaffolded questions. And I think that's important to remember, is that it's not just here's a bunch of materials, have at it. But she was asking, is it heavy? What does it feel like? She's trying to get them to think. And in this particular example, they're going to be building wrecking balls. So they're probably going to want something heavy. And she's starting to feed that without just telling them, but to get them to draw attention to, what kinds of materials might work best without saying that, by just asking the properties of the materials that she's giving them.
And making them open-ended. There wasn't a right answer to any of those questions. She was eliciting that thinking from them of what are they thinking, rather than that guess my head idea of, is it soft or is it hard, right? Is it, which one of these is the best materials? Tell me the answer that I want. She's just trying to figure out, what are they thinking? And it sets them up really nicely for this create phase. So here we see another of our preschool ones where they're designing a noisemaker. And this is one of my favorites. And they're thinking about which of the materials that they have available in front of them that they've already explored might help them make a really good noisemaker for a surprise party for the problem that the puppet has introduced to them. So we'll take a little look.
Go ahead. See what you can do. You gonna try some buttons?
Pom-poms are buttons.
Yoni thinks pom-poms are quieter.
Quark? No, this is a little low.
Yoni thinks Quark is a little loud. Now Yoni's gonna work on his design. Ethan will work on his design.
I will work on my design.
And Ella will work on her design.
And this is all stuff I need.
So Ethan, are you ready to test?
Yeah. First I need to put that, and this.
Does it sound louder to you?
Right? Loud. We hear the classroom in the background. It's a real classroom. There's other things going on while these students are at this center. But you see that they're trying all of these different materials and seeing what's going to make those noises. And we hear those scaffolding questions again.
Yeah, and Katie, I'm seeing all these materials, and I know that some teachers sort of panic about, things getting too messy or out of control when there's a lot of materials involved. And I see, this teacher did a really good job of keeping things, or you could see everything was in a bin. I also noticed as kids were, maybe spilling some buttons, she was putting them back in to sort of keep things organized. So I think all those, background teacher components are things to be mindful of. So as you're setting up, so that way you don't have something that's crazy in the create phase where you think, well, I'm never doing that again because it was a disaster, right? But so thinking about how are you going to organize your materials so students can create in a purposeful fashion. And you saw these kids were purposeful. They weren't just throwing everything into their shaker, but they were selecting certain things. And that's what makes it, to me, intentional and more engineering, because they're being really thoughtful and purposeful.
And that's one of the really good things about the materials that we have with Yes and EIE is that all of that has already been thought through by the curriculum designers about like, how will you put these materials out? What, right? To say to put things into certain bins or buckets or bags, making sure that the materials are things that are easily accessible and identifiable to children. We may need to teach them the names of things like paper clip and clothespin, but it's not a completely foreign thing. These are tangible,
right,
familiar materials that they will bring some prior knowledge to, right? Like they know what a pom-pom is. They will know that that's soft, but that a paper clip might be hard, right? They will have some ideas coming in, and we can build on that to make sure that students are seen as assets. So let's take a look. Oh, not that one. We're going to take a look at the improve phase here last. And this improve phase is from a kindergarten lesson. So it's a little bit different. You won't see the little box here, but we're going to hear them think about what can they do differently for their design.
Here's the cool thing is that we get to experiment. And sometimes when we do it, it might not work. And that is a very frustrating thing for engineers, is when they keep trying and trying and trying and it just doesn't work. But engineers never give up. Would you like to try a different material? Okay, which one would you like to try?
When I was in soccer, I fell down and I did not give up.
I love it. I love it.
So we're seeing that persistence in that improve phase. And this is what we were talking about with making sure that they know that they can try again, that we don't get that frustrated, sad, pouty face that we see, honestly, all the way up through middle school. I have seen that in classrooms when kids that things don't work because they've taken ownership of these designs, but they learn very quickly. All right, let me try it again. I'm gonna do it again. I'm gonna fix it.
So Katie, how do you feel teachers can offer that support without overstepping? It's like if a student's shutting down because they're frustrated, rather than the teacher being like, oh, well, why don't you try this, and sort of giving them, how do you think teachers can support that?
So there's a couple of different things, and again, depending on the grade. I think with preschoolers, it might be something where you give them, we were just talking about this semi-closed, right? This idea of giving choice, right? We're not saying there's a right answer, but it's almost like the behavior choices, right? Would you rather pick up all of the meth, or would you, right? Would you like to try this material? These are available. You didn't try these. Or asking those probing questions. Why do you think that didn't work? Okay, so what could you do differently? And I think it's about making that relationship with your students that they know that it's a question and not a command to do something.
And I think that's something teachers just need to, right. And also just to practice with your own teacher language, right? Like, how are you going to structure your questions so that you're not leading them or asking guiding questions or taking that ownership away from them? And that can be hard to make that shift, but it's worth practicing, so that way it just becomes the everyday language that you're using.
And that's when I work with both pre-service and in-service teachers, one of the big components that I work with teachers on is this idea of talk moves and back pocket questions, of trying to think about these things ahead of time. Like, okay, where might my students get stuck? And what are some questions that I can have in my head already that I'm not thinking of all of them as an improvisation? I've got a little bit of a script and a cue cards in the back of my head. Even if you need to actually put them on index cards and have them in your back pocket, right? You have this for yourself. And a lot of these we've already thought of with the YES materials, and you'll see them in the curriculum where we'll say like, hey, this is where you might say this to students. You might ask this question. If a student is stuck, try this. And so those are all very unit dependent based on the task at hand.
Yeah.
Here's the cool thing is,
there we go again. So we're gonna move a little quicker through this than we had planned, but we want to talk about like, why is this successful? And part of this is making sure that we have this framework that engages every student. And so part of this is this idea of socially engaged. And so you saw the teacher with the puppet earlier. She was situating the problem for the students through the puppet. And in kindergarten, they have a read aloud story that they're getting to. And so we need that to be developmentally appropriate. What these things look like for preschoolers and kindergartners is not what we want it to look like for our middle schoolers. But we need our preschool and kindergartners to start, right? You have to think about this as we need to teach them to count and have number sense before we can teach them to multiply and divide and do fractions, before we can teach them algebra. These skills are all going to build on each other. And so these are my friends from earlier. I said we'd hear them talk a little bit later about how they're going to make these personal connections to the thing that they're doing, which in this case is building a sun hat.
With your voice only, I want you to tell your partner what areas you need shaded and why. Go.
I need my ear and this because I don't need my neck because my hair is covering my neck. But I need my ear and my head because my head gets so hot and my and it gets like so sun and then I can't see. Yes, I know. I have a long hair, but I'm not until this. You don't stunt to it. So you need your ear too, but you didn't have much time. Your head. So we're gonna color. My hair's all over. The hair. Yeah, not coloring.
So they're connecting with this idea of needing a sun hat, right? What parts of their body need to be covered, need to be handled. And then we also think about not just their own needs, but the needs of other, of other people, right? Thinking that other people have different needs. And so we'll let this little one tell you a little bit about her nightlight that she's designed here. Lost my play button.
So I chose this one because it's the lightest, but we can still use both, because if the person isn't that scared of the dark anymore, they could flip it upside down so the light is here, and then it'll just shine here. But if they're really scared of the dark, they can go it like that, and then it'll be like that.
So she's thinking about just some fictional characters in her brain who might have different needs. She doesn't even address her own. She doesn't say, I need a nightlight. She says there's different people with different needs. And that's setting her up as she goes to think later about these bigger trade-offs in middle school when they're thinking about more systemic problems, like getting rid of shoes in landfills, and how do we deal with that? Or how do we keep medication cool as we're transporting it in places like the African Sahara Desert, right? They got to get here first.
And this could be, oh, sorry,
yeah.
I was gonna say, I mentioned earlier about how young learners are so egocentric. It can be hard. I mean, she did a great job of explaining, different people. Some might be more scared of the dark than others.
Yeah.
That you'll see that start to happen more in kindergarten, where they start to think about other people. But really, in a preschool setting, they're probably not. They're gonna just think about how something impacts them, and that's okay to start there.
Absolutely.
That's developmentally appropriate. But to start looking at, like, okay, this works for you because of your situation. Like, we were looking at those kindergartners talking about their sun hats, and the one girl said, well, my hair covers my neck. Great, so that works for you. Somebody else, where their hair doesn't cover their neck, is going to need something different. So to start to point out those different components, I think,
Right.
is an important way to get them to begin to think more critically about the impacts of their engineering.
Absolutely. And they want to think about how it solves the problem, right? So in this case, they're measuring, does the sun get through, with just a simple yes or no, right? They're not trying to measure the quantity of light, the strength of the light. Just, did we make a sun hat that keeps the sun off of the places that we wanted it to be off of? And I'm gonna move quickly through these. We're not gonna watch this video because I want to respect people's time. But key to this too is engaging students in this idea of a practice, in the things that engineers do. And we'll see those 21st century skills come back up again, right? They're communicating effectively. They're collaborating. Additionally, they're thinking about, there's that balance criteria and constraints, thinking about the different things, exploring the properties of materials. And so to make sure that we think about that, come on, advance slide, please. There we go. We've also thought about this as a slightly developmentally appropriate for preschool, right? So thinking about a problem in context, exploring materials, evaluating materials. And we've said, kind of, what do these actually look like in a preschool classroom? Right? So they're going to base their opinions of good material or design on how well it solves the problem. Not just, I chose the red pipe cleaners because I like red. It needs to solve the problem. And so I'm going to skip ahead to this guy here. In order to do that, we need to think about things with this idea of an asset-based pedagogy. We talked about them having prior knowledge and experiences, giving them familiarity, familiar tasks and tools and terminology, and being multimodal, right? So what does that look like? So here's some examples from our sun hats, and you'll see up in that top right there, my jellyfish friends there. But they're thinking about, what do they already know about hats? They're thinking about having, so you'll see our vocabulary here that's all visual. They've got a very clear problem and goal with pictures. They're allowing the students to come as they are to this experience. And the big piece is, we want them to identify as engineers in developmentally appropriate ways. So I'm going to let our little friend here tell you about it.
At first, I didn't think I could be an engineer, but then I finally decided that I wanted to be an engineer and make stuff and like help the poor people.
What happened to being a princess? You're not gonna be a princess?
I am still. I'll be a princess engineer.
Right? Very typical of our preschool kindergartners, right? I want to be a firefighter president. I want to be, a veterinarian and a ballerina. They can do both things. Both things can be true for them, but they don't even know that they want to be an engineer unless we introduce them to that idea, right?
And that's not to say that every student has to say, like, when I grow up, I want to be an engineer, but they see themselves as someone who's capable of that.
Exactly.
I love that she wants to be a princess engineer. I feel like that's a lot more realistic than my daughter who wants to be Elsa when she grows up.
That's a princess.
Yeah.
Princess. You live on a mountain. I mean, she could be, someday. Just send her outside with the snow later this year. So real quickly, we'll just let you get introduced, and then we will come back to the question that's in the Q&A. But what these resources are that are available to you, and we're running out of time here, so I want to make sure we can get to some questions. But we have our We Engineer, which was specifically designed for preschoolers. And all of these are free and available on our website. You can go and download those. I'll show you that link in just a second. All the digital materials. And these ones were meant to be done. You'll see the short time spans there because it's preschool. That's about the attention span, the amount of time you're going to get their undivided attention for. If that, we want to make sure that it's active and exploring for them. And then at the kindergarten level, it looks a little bit different. There's a few more activities. It's a little more structured, developmentally appropriate. The two that I like to talk about recently, we saw the sun hats and we see trash collectors, right? They're thinking about real problems that they can solve. And so to get to our materials, you go to yes.mos.org, super simple. You click on our curriculum and go to where you want to go. In this case, it was our elementary, and then to our pollinators unit, which is for 2nd grade. And then you just click here on download materials, and that'll take you to a Google Drive where you can just copy the materials to your own Google Drive. The link above it will take you to somewhere where you can purchase a box of stuff, right? If you don't want to have to go around sourcing all your things, you can just have it delivered all in one box to you, except like, scissors and pencils. We don't include that stuff, but all of the pipe cleaners and the clothespins and the materials that you would need, the flashlights, all that kind of stuff. And those include our teacher guides, which have all the information you need to set this up. For our Yes units, that also includes our teacher slides. We're slowly adding those for all of our EIE units. The student engineering notebooks. So we'll see here, here's our kindergartners, which hat will work best. They're circling the one, and it says the brim is big. They're practicing those literacy skills and recording their ideas. And ways
And that's a big part of that communication.
Exactly.